All right, guys, this video is about problem 3.3 from chapter 3. I'm so excited somebody sent me a question, so I'm gonna make a video about that problem. So if you ask me a question and I see your email, I can make a video about it. So here we go. This is chapter 3, problem 3.3. All right, let me share my screen here. Okay, so determining the components of a vector. All right, so over in the corner here, we have our vector, and it looks like the x component of our vector, um, the x component, it starts at 5. No, it starts at 3, and it goes till 8. Okay, so the x component of the vector is 3, and then it starts at -2 and it goes down to -4. Okay, so I'm gonna make a note of that. Okay, actually I'm gonna just redraw the vector over here in my notebook. But basically, I'm gonna say AX has a length of 5. Okay, and AY has a length of -2y. Okay, let me show you what I'm writing over here. Okay, so I'm taking notes on this problem. Okay, and then I'm going to draw it. And this problem, what's important to realize is that it does not start at the origin. Okay, it starts over here at, what is that? That's -2, 3. So our vector starts right here. Okay, this is +3, and it goes over here 1, 2, 3, 4, 5 till 8. So this is AX here, and then it goes down 2, and it looks like this. Okay, and here's our vector. This is AY, and this yeah, AY. And here's our vector A. Okay, so what is the magnitude of the component shown in the vector? Well, I can see here, right? We're just going to use the Pythagorean theorem, and we're going to say the magnitude of A, right? This is our notation. It means square it and take the square root of it, or just use the Pythagorean theorem, basically. Okay, so here we go. The x component, the length is 5, so it's going to be 5 squared. Plus the length of this, it's -2, okay? But when I square it, that just becomes, it's a 2 that goes away. Okay, so I'm going to have in here 25 plus 2, yeah, 25 plus 2 squared, that's 4, and I'm going to take the square root of that. Okay, so that's going to be the square root of 29, and the square root of 29, I'll just do that on my phone real quick. Well, I know 5 times 5 is 25, and so it's probably about 5.4, I'm guessing. Okay, so 25, and then I take the square root of that. No, dang it. Okay, it's 29, so 29, I'm going to take the square root of that. Okay, so yeah, it's 5.385 or 5.4. Okay, so let's put that in there. 5.385 or just 5.4. Okay. So yeah, when I round it off, 5.4. Okay. And that's important because it does not start at the origin. All right. So let's put in our answer here, 5.4. Submit. What what is the oh What is the magnitude of the component vector AX shown oh my gosh. I didn't see AX there. I didn't see it. I thought it said A. It's 5. I read it there. It's 5 right there. Okay. What is the sign of the Y component? Well, the Y component, it definitely starts at -2 and it goes to -4, so it's pointing downwards. And so that is definitely a negative. Okay. So that one's gonna be negative. Okay. And then what do we got? Was that the end of that one? Go to the next now. Did we miss one? Yeah. Oh, okay. What is the X component? Oh, wait, shoot. We're back here. Oh, we didn't submit it. Oh, what is the sign of the Y component? That's a negative. Yeah, I'm gonna submit that. Okay. Ah, it shows me C. Okay. Now combine the information given in the tactics box above to find X and Y components. BXE and BY as shown in figure 2. Oh, there's a figure 2 here. Oh, I did not see figure 2. That was sneaky. There's a little tab there. Okay. Now combine the information given the tactic box above. Okay. Practice. Okay. When a vector A is decomposed into components of vectors AX and AY parallel to the coordinate axis, we can describe each component vector with a single number, a scalar called the component. The tactic box describes how to determine. Wait, where's the tactics box? Oh, there it is. Okay, absolute value of AX of the X component of AX is the magnitude of the component vector AX. Okay, yeah, we can look at that and just tell how long B of X is. Okay, the sign of AX is positive if A of X points in the positive X direction and it's negative points in the negative. Okay, the Y component of AY is determined similarly. Yeah, let's do it for BX here. All right, well I'm looking at the plot and I can see that my vector starts, yeah, my vector starts at negative 3.5 if I look at this really carefully. Okay, I'm gonna zoom in here. It starts at negative 3.5 and it goes to negative 5.5. So I think that one is negative 2. It looks like negative 2. So I'm gonna put a negative 2 there. And then I guess there's a comma. I hope I don't mess up the syntax. And this goes downwards, starting at 3, and it goes through the origin, and it goes to -2. So that's -5. Okay, we're gonna go -5 here. Yay! We did it. Okay. So that's really the key is identifying the X and Y components of our vector here. Okay. And we see that the origin or it does not start at the origin. The beginning of our vector is +3 and it goes to 8. And so we subtract the difference between those. Basically, it's 5 meters long in the X direction and it's 2 meters long in the Y direction, pointing in the negative direction for vector A. All right. Thank you for watching and send me more questions. I'll make videos. I'm just sitting in front of my computer here making videos. So send me your questions. I love questions and I love to make videos. Thanks for watching.